Hello there and welcome to the GCSE revision video. Here we're looking at pyramids, cones and spheres. Let's first have a look at the formulae for these shapes. So you'll get these kind of formulas in the exam. So next to the question you'll get the appropriate formulas that you'll need. So for example you might get a little box that looks like this with the formula for the volume of a cone in it, or for the volume of a sphere in it. So r is the radius of the cone and h is the vertical height of the cone, not the slanty height, the vertical height. And for the volume of a sphere, you get this formula here. It's 4/3 pi r cubed, where r is the radius of the sphere. Or you might get a little box like this in the top right of our screen, where it gives you the volume of the sphere and the surface area of the sphere, 4 pi r squared. Or it might give you the volume of a cone down here, along with the curved surface area of the cone. That doesn't include the bottom, so if you need to put the bottom in there, you'll need to add in the equation of a circle. It's just the curved surface area around the cone on the top here, well, it's pi rl. Okay, so what won't you get in the exam, that's important for you to now remember, is these two formulas here. Volume of a prism is the area of the cross-section times the depth. What does that mean? Well, if you've got a similar shape like a Toblerone, then what I mean by the area of the cross-section is this area here, and then you just multiply it by the depth of the shape. Or it could be like a circular prism, where you need to work out the cross-section area here, and then multiply it by the depth. So that's what I mean by a prism. It's a shape that's just then stretched in 3 dimensions, where you just multiply it by the depth once you've worked out the cross-sectional area. And then there's the volume of the pyramid. So if you've got, say, a square-based pyramid that looks something like this, then what you'll do is you'll work out the area of the base first, and then do base times height divided by 3. Now why do you divide by 3? Well, because you're working in 3 dimensions. A triangle has base times height divided by 2, because this is a 2-dimensional shape, whereas this here is a 3-dimensional shape. So it's area of the base times height divided by 3, because it is 3-dimensional. And what I mean by the height is the vertical height, not any slanty kind of height. Okay, let's get stuck into some questions now, so pause the video and give this one a go. Okay, so in this question here, a solid cone has height 15 centimeters. The volume of the cone is 320 pi. Work out the curved surface area of the cone, giving your answer to 3 significant figures. Okay, so not even a straightforward question to get the ball rolling here. Generally, these questions are quite challenging. So, first of all, we need to work out what the radius of the cone is, given that we know the volume. So the volume is going to be 320 pi, and this is going to equal the formula for the volume of a cone. So it's going to be 1/3 pi r squared times h, but we know the value of h, that's 15. Okay, so what I'm going to do now, first I've set up here a volume of a cone equals the formula for a volume of a cone. The first thing I'll do is I'll cancel out pi from both sides, and then I'll simplify the 1/3 and the 15 together. So I'll leave the 320 on the left. 1/3 of 15 is 5, so it's 5r squared. The next thing I'll do from this side to this side is divide by 5. So divide by 5 on both sides. 320 divided by 5 will leave us with 64. So 64 equals r squared. I've divided by 5 on both sides there. And then we square root, so r equals 8. Okay, so now that we know the radius, we now need to work out the curved surface area. But for the curved surface area, we need L. So what we're now going to do is work out what L is by doing a little bit of Pythagoras theorem here. L equals the square root of 15 squared add 8 squared. So let's get the calculator out for that. 15 squared add 8 squared, and that gives us 17. Okay, so now that we know the slanty height is 17, let's now work out the curved surface area. So curved surface area is going to be equal to 4 pi RL, so it's going to be pi times the radius, which is 8, times the length of the diagonal, which is 17, and let's multiply 8 and 17 together, 136 pi, but they would like our answer to 3 significant figures, so let's do that, and that's 427 centimetres squared, because it's an area. Lovely, there we are. So that's the answer for this question here. So lots of different stages for that question. Very well done if you got through that one. But there we are. That's how we do these kinds of questions here. And don't forget, you'll always get this little box on the left-hand side here, or on the right-hand side maybe, that will give you the formulas that you need for these sorts of questions. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so in this diagram shows a hemisphere with a diameter 8.4 centimeters. Work out the volume of the hemisphere. So first of all, we need to work out the radius, and the radius is going to be 4.2 centimeters. It's always half the diameter. Then we'll work out the area for the hemisphere. It's going to be half of this formula here. So it's just going to be 2/3 times pi times 4.2 cubed. So I've halved the 4 to a 2, and that's halved the volume of the sphere into a hemisphere. So it's going to be, I'll do this on my calculator now, 2/3 times pi times 4.2 cubed. And that gives us 155 to 3 significant figures, 155 centimeters cubed that will be, because it's a volume. Great, that question wasn't too bad. Let's move on to the next one. Pause the video and give this one a go. Okay, this question here looks a little bit challenging. The volume of S is 576 pi centimeters cubed. So this is a quarter of a sphere. So if it's a quarter of a sphere, it's just going to be 1/3 pi r cubed, because we've got 4/3 for the whole thing, so it just must be 1/3 for a quarter of it. And this will equal 576 pi. So cancel out pi on both sides and times by 3 onto the other side. You'll get 576 times 3, which is 1728. Then do the cube root of this on both sides. So it's going to be the cube root of answer, and that gives us 12. Right, so we've now got the radius value of 12. Now let's go ahead and work out the surface area of S. We'll have to break this up into 3 parts. We'll call part A the curved surface area, and then we'll call part B and part C these parts of the shapes here. So for part A, it's going to be a quarter of the normal surface area. So if the normal surface area is 4 pi r squared, then a quarter of it will just be pi r squared. So that's going to be 144 pi, because that's 12 squared times pi. So that's A. Now let's move on to B. B is just a half of a circle. So the circle is going to be pi r squared, but it's going to be half of 1, so it's a half pi r squared. So that's going to be 4 squared is 144, but then half it, we're going to get 72. So 72 pi. And exactly the same with C, because it's exactly the same shape. So in total, when we now do A plus B plus C, we're going to get 288 pi. But then our answer is required to 3 significant figures, so 288 times pi will give us 905 centimeters squared. Centimeters squared, because it's a surface area, this. And there we are, that's the answer for this question here. Let's move on to the next one. Pause the video and give this one a go. Okay, this question is not too bad at all. Let's first of all halve the diameter, so that will give us the radius. And then we want to work out the volume of the hemisphere, so it would just be half a sphere. So the volume is going to be 2/3 pi times the radius cubed. The reason I've done 2/3 here is because it's half a sphere, so I've halved the 4 to a 2. So let's grab our calculator and type this all in. 2/3 times pi times 9.3 cubed. And that gives me three significant figures. It's going to be 1680 centimeters cubed. That one was not too bad at all. Work out the radius, work out the volume. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so this question looks quite difficult. So the diagram contains a container made from a cylinder and a cone. The container has a vertical axis of symmetry. The cylinder has height 20 centimeters and radius 15. The cone has height 18 centimeters and base radius of 15. There are 9 litres of water in the container. So just to start off with, just a reminder of what a litre is. A litre is 1,000 centimeters cubed. So therefore 9 litres is obviously going to be 9,000 centimeters cubed. Okay, so the first thing to do then would be to work out the volume of the cone on the bottom then. So the cone is going to be 1/3 pi times 15 squared times 18. And this is going to give us a volume of 4241.15 ... So that's the volume on the bottom. So I suppose what we need to now work out is how much we've got left. So left over will be 9,000 minus 4241, which will equal 9,000 minus answer. So that would be 4759 approximately. Right, so now what we've got here on the bottom is that's going to be full up with this volume, and then on the top here it will come up to some height that will be containing this part of the volume, and in total that will be 9 litres. So what I now need to work out, let's just call that height x. If you don't know something in maths, just call it x, then work it out. So the volume of this cylinder on the top there is going to be pi r squared. That's the volume of the cross section times by the height. So the volume is going to be pi r squared, and r is 15 here, so pi times 15 squared times the depth of x equals 4759. That's how much water we want it to be containing left over. And we're going to work out x here to work out the depth of the container. So what we're going to then do is take our 4759 and divide by pi and divide by 15 squared. And that will leave us with x. So take our answer, divide by pi and then divide by 15 squared. And it will leave us with 6.73. So that is the depth of the container from the from where the container starts, not above the cone. So the height of the surface of the water in the container above the vertex of the cone. So if this is the vertex of the cone, so we'll just need to add on 18 to our answer, and that would be 24.7 to 3 significant figures. So the height above the vertex here, so the total height that water will go up to is 24.7 centimeters. Lovely, there we are. That's the answer to this question here. Tricky little question, that one. Lots to do there. Make sure you keep track of your answers by just writing little words next to your calculations, just so you remind yourself what you've just done. Okay, so let's move on to the next question. Pause the video and give this one a go. Okay, so in this question here we have a cone on top of a hemisphere. Now the key for this question here is to identify that your radius is going to be the value 3, and that's going to be in all directions. So it's also going to be a radius of 3 in that direction as well. So the total volume of the hemisphere is k times pi, where k is an integer. Work out the value of k. So we want to work out basically the volume of the shape in terms of pi. So let's work out the area of the top bit then. So the area of the cone on the top is going to be 1/3 times pi times 3 squared times 10. So I can cancel out one of my 3's there and there. So it's going to be 30 pi. Now don't work this out. Don't type this into your calculator. Just leave it as 30 pi. So what I've done there is I've cancelled out one of the 3's on the top and the bottom to leave us just with 1 and 3 on the top. 3 times 10 is 30 times the pi, so it's 30 pi. The area of the hemisphere on the bottom is going to be half a sphere, so it's just going to be 2/3 times pi times 3 cubed. So I'm going to cancel out one of the 3's on the top and the bottom here. So that'll leave me with 2 times 3 times 3. That would be 18 pi. So the total area here is going to be these two added together. That would be 48 pi. So k is equal to 48. And there we are. That's the answer to this question. So let's just work out a couple of volumes. Don't work out the actual proper answers, the decimal answers I mean, and then just add them together and work out what goes in front of k. What goes in front of pi I mean. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so the volume of this hemisphere is 250 over 3 pi. Work out the exact surface area of the solid hemisphere. So we need to work out the radius here. So it's going to be 250 over 3 pi equals the volume of the sphere. Yeah, it's going to be, it's hemisphere, isn't it? So it's half of this. So that's 2/3 pi r cubed. So the first thing I'll do is I'll cancel out the pi on both sides. I'll cancel out the divide by 3 on both sides and divide the 2 onto the other side to give me 125 equals r cubed. So therefore r equals 5. Cube rooting both sides. So now that I know that r is 5, I now need to work out the surface area of the shape. So I'll work out the curved surface area of the shape first. That's for the whole sphere, so I need to divide this by 2. So for section A here, I'll put section A and section B. For section A, it's going to be 2 pi r cubed. So 2 pi r squared actually. So that's going to be 2 times pi times r squared. So 2 times pi times 5 squared. Now 5 squared is 25 times 2 is 50. So it's 50 pi on the section A there. Section B on the top, that's just the area of a circle, so that's pi r squared. So that's going to be 2 times, sorry, no, not 2, just pi times 5 squared, which is going to be 25 pi. And then add the 2 together, will give you 75 pi. So there we are, the answer to this question. The answer is 75 pi centimeters squared. So give your answer as a multiple of pi. I've done that. It's 75 times pi. And there we are. That's the answer for this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this question here, it says that the radius of the base of the cone is 5 centimeters. The total surface area of the cone is 90 pi centimeters squared. Work out the volume of the cone. Okay, so the surface area is a combination of the curved surface area on the top and the circle on the bottom. So let's just do the circle on the bottom. That would be pi r squared for that surface area on the bottom there. So that would be 25 pi. So the leftover on the curved surface area is going to be 90 take away 25 is 65. Let's grab our formula for that. So we don't know what L is at the moment, so we'll work out what L is here. So it's going to be pi times r times L equals 65 pi for the curved area on the top, because I've subtracted that circle on the bottom. We know that the radius is 5, so it's going to be 5 pi L equals 65 pi. So cancel out the pi's on both sides, cancel out 5 on both sides, and you're left with L is 13 centimetres. Now that we know that L is 13 centimetres, we can work out the height of this cone here by a little bit of Pythagoras. If I know that that's 5, that's 13, I've got a right angled triangle here, so the height of the cone is the square root, and the 13 is the hypotenuse, so it's 13 squared minus 5 squared is 12. So we now know the height of this cone here is 12. And now we need to work out the volume of the cone, so that's going to be a third times pi times r squared, that would be 5 squared times 12 times 12. So if we multiply these numbers together, you can do that on the calculator or just by seeing it, so the third and the 3 from this 12 will cancel out, and it will be 25 times 4, which is 100, times the pi, so it's 100 pi. And the volume units here will be centimetres cubed. Lovely, there we are. So lots to do in that question there. So it was to work out L first, then we had to work out H, then we had to work out the volume, all by carefully keeping track of what we'd done so far in the question. And this could have been easily a non-calculator question as well, because each of these calculations I didn't need a calculator for, so don't be surprised if this appears in a non-calculator test, but it's more likely to appear in a calculator exam. Right, let's move on to the next question. Pause the video and give this one a go. Right then, let's get started on this one then. So the hemisphere has a total surface area of 16/3 pi, so that would be the top and the curved bottom. The hemisphere has a volume of k pi centimetres cubed. Find the value of k. So what we need to do then is, first of all, work out the surface area. So I'll divide it into parts A and B. So A, I'll start down here. A is going to have, well, we don't know what the radius is, so I'm just going to refer to the radius as r. So it's going to be pi r squared as the area on the top. Then on the bottom, for part B, the surface area is going to be 2 pi r squared because it's half of a total sphere, because it's only a hemisphere, so it's 2 pi r squared. So in total here, the surface area equals 3 pi r squared. So therefore, the total surface area is given by this expression here. So 3 pi r squared equals 16/3 pi. The first thing I'll do is I'll cancel out the pi's on both sides, and I'll divide the 3 onto the other side. So it's going to be r squared equals 16/9. So therefore, r equals square root both sides, 4/3. Great, so we now know what the radius is. The radius is 4/3. And now we need to work out the total volume of the hemisphere. So the volume is going to be 2/3 pi r cubed, because it's only half a sphere. So the volume is going to equal 2/3 times pi times 4/3 cubed. So let's now work that out. I'll grab my calculator to do that calculation, but I won't times by pi because I want my answer to be a multiple of pi. So it's just going to be 2/3 times brackets 4/3 to the power of 3, which gives us 128/81. 128/81 pi. And there we are, that's the final answer for this question here. So k is representing 128/81 over 81. Lovely, there we are. So that's the answer for this one. Let's now move on to the next question. Here we are then. Pause the video and give this question here a go. Okay, so in this question here, the cylinder has radius r and height h, and the sphere has radius 2r. The volume of the cylinder is equal to the volume of the sphere. Find an expression for h in terms of r. Simplify your final answer. So, let's work out the volume of this cone over, so this cylinder over here is going to be the area of the cross section times the depth. So that's going to make it pi r squared h. So that's the volume of the sphere of the cylinder, and the volume of the sphere is going to be by this formula up here. So that's going to be 4/3 times pi times 2r cubed. So let's simplify what we've got on the right hand side. So it's going to be 2 cubed is 8. 8 times 4 is 32, so it's 32 over 3 pi r cubed. So I've cubed the 3 and multiplied it at the front. The next thing I can do is cancel out the h's on both sides. And now I'm going to divide by r squared. So I'm going to divide by r squared. And what I've done here is I've divided by pi effectively. So it's going to be h equals 32 over 3. Now r cubed divided by r squared, subtract the powers and you've just got r left over. Or effectively you're doing r times r times r divided by r times r. So when you cancel out your r's, you're left with just one single r. So there we are. That's the answer for this question here. H equals 32 over 3 r. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so in this question here it says the radius of the base of the cone is 2√3, the slant height on the cone is L, the total surface area of the cone is 36 pi. Work out the exact value of L, give your answer in the form 2√a. Okay, so what we need to work out first is an expression for the surface area. So that's going to be the curved bit on the top, we'll call that part A, and the base on the cone B. So for A, the surface area is going to be pi RL. So it's going to be pi times 2√3 times L. And the surface area on the base is going to be pi r squared. So it's going to be pi times 2√3 squared. And 2√3 squared is going to be 4 times 3, it's 12 pi. So when we add these two together, we're going to get 2 pi, so 12 pi plus 2√3 pi L. And that's going to equal, it says here, this total surface area is 36 pi. Okay, so let's take away 12 pi from both sides. So take away the 12 pi, take away that 12 pi. So we've got 2√3 pi L equals 24 pi. Let's now divide by the pi on both sides. So divide by pi. And we get 2√3 equals 24. L, so L needs to go on the left. And then we'll divide by 2√3. So it's going to be L equals, well, 24 divided by 2 first of all is 12. And then that would be divided by √3. And then we just need to rationalise that denominator. So it's going to be 12 over √3 times √3 over √3. And that will give us 12 √3 over 3. And we'll simplify that, cancel out a 3 from the top and the bottom, 4 √3. give you your answer in the form 2 root a, so we need to put a 2 into there. So 4 root 3 is going to be equal to 2 root 12. It's a bit of a strange way of putting it, but there we are. That's our final answer. 2 root 12 is the answer to this question. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, the writing has got quite small here. I do apologise for that. If you come out of the video and scroll down in the description of the video, there'll be a link to all these questions. So you're very welcome to do that and have a look at what the question says there. So, the diagram of the solid shape made from a cone and a cylinder. The cone has a radius of 10 centimeters and a height of 10 centimeters. The cylinder has a radius of 10 centimeters and a height of 10 centimeters as well. The center of the base of the cone coincides with the center of the top of the face of the cylinder. Total surface area of the solid is A. Show that A is equal to this. Right, we're going for surface area this time. So A will equal, so let's divide it into top curved surface area here, Y, and bottom Z. Don't need to use A, B, and C because I've already got A in my question. So, the top bit, that's going to be, the curved surface area is pi RL, so it's pi times 10 times L, but I don't know what L is. I think I'll have to do a small calculation for L. So if 10 is here, and the height of this cone here is 10 as well, then it's going to be 10 squared. There's going to be a Pythagoras calculation here of 10 squared plus 10 squared square rooted, and that would be 10 root 2. So to work out this curved length here, you just do a small calculation of 10 squared plus 10 squared, and that will give you 10 root 2. So that's the value for L. So my curved surface area is pi times R times L. So that's my calculation here. And I'll simplify that to 100 root 2 times pi. So that's the curved surface area. So moving on to the next part, which is Y. Now that, when you stretch it out, would just be a rectangle. It'd be a rectangle that will have a height of 10, and the width of the rectangle will be the same as the circumference of the cylinder, of the circle on the top there. And the circle's circumference will be 2 pi r, so it would be 2 times pi times r. The r is 10, so it would be 20 pi. So the area of this rectangle is just going to be 200 pi, base times height. And then for z, it's just going to be the area of the circle, so that would be pi r squared, so that would be 100 pi, because 10 is the radius, so 10 squared is 100, so it's 100 pi. So now what we need to do is just add all of these bits together. So it's going to be 100 root 2 pi, add 200 pi, add 100 pi. So when we simplify the last two bits, it's going to be plus 300 pi. And then it looks like our answer wants us to factorise out pi, so it would be pi times 100 root 2 pi plus 3, sorry, pi is being factorised out, so we don't need to write it in there, times 300 close brackets, and then we just need to rewrite it in this order, so it would be brackets 300 plus 100 root 2, close brackets, pi, final answer. There we are, so that's centimetres squared. Lovely, there we are. So we broke the shape down into 3 separate parts there to work out all 3 bits of the surface area. And yeah, some quite difficult calculations there, because we had to work out L, a little bit of Pythagoras. We had to work out the circumference of the circle to get the area of the rectangle, and lots of areas of circles and stuff. So yeah, good. That was a difficult question. That one, big question, involving lots of different bits there. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so in this question here we have two solid spheres, each made of radius r, fit exactly inside a hollow cylinder. The radius of the cylinder is r, the height of the cylinder is 4r. Well, that makes sense because the radius to the centre of that circle will be r, then there'll be another to the bottom of the circle, which will be another r, then it'll be to the middle of that circle again, which will be r, and then to the bottom of the circle, which will be r again. So they didn't really need to tell us that, but yeah, that's right, 4r. The volume of the space inside the cylinder not occupied by the spheres is 125 over 6 pi. Calculate the value of r, show you're working clearly. So what we need first is to do the cylinder, take away the two spheres. And that will equal 125 pi over 6. So the cylinder then, so that's going to be area of the cross section times the depth. So that's going to be pi r squared times another 4r. So it'd be pi r squared times 4r, and that was simplified to 4 pi r cubed. The two spheres, well, it's going to be the volume of this sphere here, but multiplied by 2, so that's going to be 8 over 3 pi r cubed, and that will equal 125 over 6 pi. So let's write that all out. Okay, so first of all, let's get rid of all the pi's in this question. So let's just cancel it down to 4r cubed minus 8 over 3r cubed equals 125 over 6. Now let's combine the left-hand side because they're both r cubed. So the 4 could be represented as 12 over 3. That's the same as 4. So 12 over 3 minus 8 over 3 is 4r cubed over 3. Equals 125 over 6. Let's, what should we do first? Let's times both sides by 6. Now when I times the left-hand side by 6, I've already got to divide by 3, so I should only really double the top. So it's 8r cubed equals 125. Let's now divide both sides by 8. So that's going to be r cubed equals 125 over 8. And then we need to cube root. So that's going to be r equals 5 over 2. And there we are, calculate the value of r. R is 5 over 2. Lovely, there we are. So that's the answer to this question then. Clearly setting out the working. It's really nice here actually. Cylinder take away two spheres equals 125 pi over 6. You can see the algebraic manipulation as you go down the page. Make sure your algebra does go down the page. It's not dotted all over the page. It's just in one clear, nice format. Okay, let's move on to the next question. Pause the video and give this one a go. Right, okay, let's get going on this one then. So the base of the cone is a horizontal circle with radius 4.5. Let's put that on. AB is a diameter and OV is the height of the cone. The curved surface area of the cone is 130 centimeters squared. Calculate the size of the angle AVB, so this angle at the top here, and give your answer correct to one decimal place. So the curved surface area is 130. So I need to pull out this formula here to get me the length of the diagonal. That length there. So it's going to be pi times r times L equals 130. So it's going to be pi times 4.5 times L equals 130. So what I'll do then is I'll divide by 4.5 and then divide by pi. Divide by both of them at the same time. So grab your calculator, 130 divided by 4.5 and then divide by pi, which will give us 9.20 basically. So L equals 9.20. But I'll leave that answer currently in my calculator so that I can use it as the answer button in a second. Now, if I work out the angle at the top here, x, I could just double it from this right angle triangle here. So this is going to be the opposite side, this is going to be the hypotenuse, so it's going to be a sine inverse, so x equals sine inverse 4.5 over 9.20. I'll use the answer button at that point on the calculator. So sine inverse, fraction button 4.5 over answer. And that gives me 29.3 basically. And then I'll double it to get the actual answer of AVB. AVB equals double that answer times 2. That gives us 58.6 to 1 decimal place. 58.6 degrees to 1 decimal place. And there we are, that's the answer to that question. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this question here we have a cylinder and a hemisphere. The cylinder has radius 3.4 and length 8.3, and the hemisphere has a radius of 3.4 as well. Calculate the total surface area of the solid shape. So let's divide it into 3 parts, A, B and C. So for A, it's going to be the curved surface area on a sphere. In fact, let's work up here. Curved surface area on a sphere is going to be 4 pi r squared, but it's a hemisphere, so it's half of that. So it's 2 pi times 3.4. And that's going to be, let's grab our calculator, oh, it's 3.4 squared. So I'm just going to leave that alone actually. I won't type that into the calculator yet, so I'll add all my results together at the end. The next one is going to be this middle component here, section B. Now if you unfold section B, it will actually give you a rectangle. And the rectangle on the length will be 8.3, and then on the height is going to be, when you unravel it, is going to be the circumference of the circle. So it's going to be 2 pi r, so that would be 6.8 pi. So I've doubled the radius and then times it by pi. So it's going to be 6.8 pi high. So it's going to be 8.3 times 6.8 pi. So I'll just leave that alone there. And then the area of the circle on the side is 3.4 squared times pi. So now what I'll do is I'll type all of these calculations into the calculator all in one go, adding them up together. So bear with me whilst I do this, everyone. So it's 2 times pi times 3.4 squared. Oh, I'm typing something wrong there. 2 times pi times 3.4 squared, and then add 8.3 times 6.8 times pi. I'll put that in brackets actually, good to use some brackets on the calculator here. Bear with me everyone, this is quite a long calculation. And then the last bit is brackets 3.4 squared times pi, close the brackets, and we get an answer of, now to 3 significant figures, the answer is 6510 to 3 significant figures, and that's going to be centimetres squared because it's the surface area. Lovely, there we are. So that's the answer to this question here, 6510. Let's move on to the next question. Pause the video and give this one a go. Right, so in this question here, the diameter of the circle is 10a. Now generally we don't need the diameter, we need the radius, 5a. The height of the cone is 12a. The total surface area of the cone is 360 pi. The volume of the cone is k pi. Find the value of k. So what we need to do then is to work out the total surface area. We need to divide the shape into different parts. We'll call part A and part B. So for part A, what we need first is the length L on the side of the cone there. So what we need to do first is a Pythagoras calculation of 5a squared plus 12a squared, and all of it's going to be squared. So that's going to be 25a squared plus 144a squared, which is going to be square root of 169a squared, and that is 13a. So we now know the length on the diagonal there is 13a. We can work out the curved surface area of the cone as part A. So it's going to be pi times r, which is 5a, times L, which is 13a. We just worked that out. So it's going to be 65a squared pi. Lovely. And for part B, it's going to be area of the circle on the bottom. So that's 5a squared. So it's 25a squared pi r squared. So then we'll add it up together. So the total surface area is going to be 90a squared pi. And now we know that the total surface area is 360 pi. So it's going to be 90a squared pi equals 360 pi. So we'll cancel out the pi's on both sides. If we divide by 90, we get a squared equals 4. So therefore a must equal 2. Now we need to work out the volume of the cone, so that's going to be this formula up here. The volume is a third times pi times r squared. Now the radius is 5a, but a is 2, so it's now 10. So it's 10 squared, and then it's times h. H was 12a, so that would be times 24. Write your answer as k times pi. So if we simplify all the numbers that we've got around here, divide that by 3, we get 8. That's 100 there, so it's 800 pi. And there we are. So the value of k is 800. Lovely, there we are. So lots to do in that question. Pythagoras calculation to work out the diagonal length on the cone there. Then we had to work out the surface area of the cone, the surface area of the circle on the bottom, add them together, solve the equation equals 360 pi. Then we worked out A, then we worked out the volume as 800 pi. Lovely, there we are. So that's the answer to this question here. Let's move on to the next one. Pause the video and give this one a go. Okay, so it says here the radius of the cylinder and the radius of the hemisphere are both 10. The height of the cylinder is 10. The total surface area of S is 1000 pi. Calculate the value of H. So, for surface area, we need to break our shape into individual parts. So we've got A, B, and C. So for A, it's going to be half of a curved surface area. That's 2 pi r squared. So it's going to be 2 pi times 10 squared. So that would be 200 pi. The next bit, B, is actually when you unfold it, it's going to give you a rectangle. Let's think about the rectangle. The height of the rectangle is going to be h. The width of the rectangle will be the circumference of the circle. So that's going to be 20 pi. So the area for B is going to be 20 pi times h. And then for C, that's just a circle, pi r squared. That's going to be 100 pi. So let's now add all of this stuff together. So it's going to be the total surface area S is going to be equal to 300 pi. Add 20 pi times h. And this equals 1000 pi. So let's subtract the 300 onto the other side. So you get 20 pi h equals 700 pi. Divide pi on both sides and then divide by 20. So 700 divided by 20, I believe, will be 35. Just double check that on the calculator, don't want to leave you with a mistake. 700 divided by 20, yeah, 35. 35 centimetres high is this cylinder. Lovely, there we are. So that's the answer for this question here. So common strategy here, if you want to work out the surface area of some complicated shape, break it up into individual parts, add the parts together, and then solve the little equation that equals 1000 pi. Lovely, there we are. So let's move on to the next question. Pause the video and give this one a go. Right, so this question's been put together in a bit of a higgledy-piggledy way, but let's go for it. The total height of the solid is 5x, but if this radius here is just x, then the height of the cone here is going to be 4x. So the first thing I saw there. The radius of the cone is x, the radius of the hemisphere is x as well. Yeah, lovely. Let's move on to the next part. A cylinder has the same volume as the solid. The cylinder has a radius 2x and a height x. Find a formula for h in terms of x. Give your answer in the simplest form. Okay, so for the top here, a hemisphere volume, is it volumes we're working with? Yeah, volumes is going to be 2/3 pi times r squared. So that would be x, so x cubed rather. So that's the hemisphere, and then the cone is going to be 1/3 times pi times the radius squared, so that would be x squared, and then times h, which would be 4x. So the cone, when that simplifies, would be 4/3 pi x cubed. So the total, when you add those two together, 2/3 add 4/3 is 6/3. 6/3 is equal to 2. So it's 2x cubed. That's the total for this shape over here. Now let's work on the cylinder. The cylinder is just going to be the area of the cross section, so that would be 2x squared times pi and then times h. So when you expand this, it's going to be 4x squared 4x squared pi times h. Now that we know the two are equal, so it's going to be 2 pi x cubed equals 4x squared pi h. Let's cancel out a pi on both sides, and let's divide by 4 on both sides. So that'll leave us with a half x cubed equals x squared h, and then we'll divide by x squared. So now we're going to do x cubed. Now remember, x cubed is x times x divided by x squared, which is x times x. So if we cancel out two x's from the top and bottom, we're left with just a single x. So it would be a half x equals h. And there we are, that's the answer to this question here. So lots of individual volumes worked out here, adding them together, setting them equal to each other, solving a little equation, and we get h equals a half x. Lovely, there we are, that's the answer to this question here. Let's now move on to the next one. Pause the video and give this one a go. Right then, so in this question here we have a shape called a frustum. It's made of glass. The glass has a density of 2.5 grams per centimetre cubed. Work out the mass of the frustum. Okay, so a frustum is basically a cone with a smaller cone take away on top. So what I need to do is volume of big cone take away volume of small cone on top. So the volume of the bigger cone is going to have a radius of 6. And the smaller one will have, so if we use proportions here, that's 10 to 15. So this is going to be a radius of 2. Because that will be 5 to 15, so that's a ratio of 1 to 3, and this is also in a ratio of 1 to 3, so this is 2 to 6. Lovely, so that's a ratio of 2. So now let's do the big, and that would be a height of 5 as well. So the big cone is going to be 1/3, so volume equals 1/3 of pi times by 6 squared times by h. H is 15. And then it'll be minus the small cone, which would be a third pi times by 2 squared times by 5. Okay, let's now work each of these out. So a third times 6 squared times 15. So 6 times 6 times 15, and then divide that by 3. Give us 180 pi. And then minus 2 times 2 times 5 divided by 3. That will give us 20 over 3 pi. And then the volume, I'll actually work this out as a value, 180 minus 20 over 3, and then times that by pi, will give us 544.5. 544.5 centimeters cubed. Okay, so now we need to work out the mass of the frustum, and we use here that the formula of density equals mass divided by volume. So if we want to work out the mass, we need to do the density and multiply it by the volume. So the mass of this frustum is going to be 544.5 times by 2.5, that's the density, so times 2.5 equals 100, what's the degree of, give your answer to an appropriate degree of accuracy. I'll give it to 3 significant figures, 1360, and the mass is going to be grams. And there we are, that's the answer for this question here, 1360 grams. Okay, let's move on to the next question. Pause the video and give this one a go. Right, then another one of these ones with algebra in. So if we've got a diameter, that means the radius is 12. And we know that the curved surface area of the cone is 2160 pi squared. The volume of the cone is V, so we need to work out the volume. Okay, so in this question here, we need to work out the curved surface area. First, we need to work out what L is. Now we know the height is 16, or 16x rather, 12x here, so I'm pretty sure this one is going to be 20x here. If you do a little Pythagoras calculation on 16 squared plus 12 squared, let's just do that quickly just to make double sure. Your x's will just stay in there as well. Yeah, 20x. So the length of L is 20x. So now let's do the curved surface area. The curved surface area is pi RL. So C, the curved surface area, is pi times 12x times L, which is 20x. So that's going to be 240x squared pi. So let's now set this equal to 2160. So 240x squared pi equals 2160 pi. Let's cancel out the pi's on both sides, and then we'll divide both sides by 240. So 2160 divided by 240 equals 9. It's always nice when that appears as a square number, because you know you're kind of doing it right then. So x equals 3. Okay, so now we need to work out the volume of the cone. So the volume of the cone is going to be a third times pi times r squared. So 12 times 3 is 36. So it'll be 36 squared times by h. And the h is 16 times 3. 16 times 3 is 48. And that's just, yeah, single h. So it's going to be 36 times 36 times 48, divide that by 3 for the third at the front. That's going to be 20736 pi centimeters cubed. So therefore V is equal to 20736. Lovely, there we are. That's the answer to this question here. So another one with algebra in. Hopefully we're getting a bit better at these ones. Okay, let's move on to the next one. Pause the video and give this one a go. Right, okay, this question's a very difficult one here. If you can't quite see it on the screen, download the worksheet in the description and you'll be able to see the question properly. The diagram shows a frustum is made by removing a cone with height 3.2 centimeters from a solid cone of height 6.4 centimeters and a base diameter of 7.2 centimeters. So it's done in half. So that means this diameter will be in half, so that means that radius would be in half. So if this radius is 3.6, this radius here will be 1.8. The frustum is joined to a hemisphere of diameter 7.2. Again, that would be radius 3.6, as drawn below. The density of the frustum is 2.4. The density of the hemisphere is 4.8. Calculate the average density. Well, the average density will be the total mass divided by the total volume. So when we get to it, that's going to be the formula that we're going to use. But first of all, let's go for the frustum at the top. So I'm going to call this F equals. Now we'll work out the volume of this thing first. So it's going to be a third. And the volume formula is down here. I'm going to do the full cone, take away the smaller cone. So it's going to be the big cone, which is a third pi times 3.6 squared times h. And the total height there will be 6.4. Then I'll take away the smaller cone on the top, so that would be take away a third times 1.8 squared. Pi will be in there as well, and then times by h will be 3.2. Okay, so let's now do that calculation. I'm going to do 3.6 times 3.6 times 6.4 divided by 3, and then times pi, and then I'll take away the answer for the second one, so that'll be 1.8 times 1.8 times 3.2 times pi divided by 3, and that will give me 76.00, 76.00. I'm going to now store this as answer A in my calculator. I'm going to use the store function and A. Okay, so that's now A on my calculator. This is centimeters cubed. Now the mass of this thing here is going to be 76.00 times the mass of the frustum is 2.4. So times 2.4 equals 182.4. I think that might be a helpful value later, so I'll store that as B. Right, so now let's move on to the hemisphere on the bottom. So the hemisphere is going to have radius 3.6. So the hemisphere, I'll call it H, equals, it's only a hemisphere, so I'll half the sphere, 2/3 times pi times the radius cubed, so that would be 3.6 cubed. And let's do that on the calculator now. So 3.6 cubed times by 2/3 times by pi. That gives us 97.7. And then the mass of the hemisphere is going to be 97.7 times 4.8. So times 4.8 on the answer. 469.0, 469.0, and I think that will be an important value later on, so I'll store it as C. Right, so now that we have the total mass, we now need to divide it by the total volume. So, I think this value here might have been an important value, so I'm going to call that D now. I'm just going to use my calculator to scroll back up to where I had that. So store as D Okay, so now we need to do this average calculation. So average. So the average density is going to be the total mass, so that's going to be B plus C over the total volume, which is going to be A plus D. So I'll now do that calculation on my calculator using the red alpha buttons. So B plus C over A plus D. And that is 15 over 4, exactly 3.75. And there we are, that's the answer for this question. And does that make sense according to the question? Yeah, 3.75 is in between 2.4 and 4.8, so it makes sense that it's about, it's in between that value, maybe a bit more heavily weighted towards the larger shape. The larger shape was the hemisphere, so it's a bit more weighted towards that, and yeah, it is. So there we are, so it's grams per centimetres cubed as the unit there. Lovely, there we are. I'm confident we got that one right. Very good, very pleased with that. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this shape here, if you can't read it again, come out of the video, go in the description, there's a worksheet available with these questions on it. So the radius of the hemisphere is 36, the radius of the base of the cone is 36 as well, the height of the cone is 53, the radius of the cylinder is r, the height of the cylinder is 2r, the volumes of the shape are equal, calculate the height of shape B. Okay, so we need to work out shape A first. So the volume of A is going to be a hemisphere, so that's going to be 2/3 pi 36 squared, add the cone, which is going to be 1/3 pi times 36 squared times 53. So let's work this all out, but we'll leave the pi alone. So it's going to be 2/3, 2 over 3 times 36 squared. 36, is that hemisphere? No, it's the hemisphere is cubed, so I need to do that cubed. And then plus brackets 1/3 times 36 times 36 times 53, and that will give me 54,000 pi. So that's the volume of the left-hand shape. Let's now set it equal to the right-hand shape. So volume B is going to equal pi r squared times 2r. So if we simplify that, that's 2 pi r cubed. So now we'll set the two equal to each other. So it's 54,000 pi equals 2 pi r cubed. So divide both sides by 2. 54,000 divided by 2 is 27,000. Cancel out the pi on both sides as well. Give us r cubed. So you can kind of sense where this might be going. Cube root both sides now. Cube root answer. And that gives us 30. So the height of shape B, the height will equal 60 centimetres in height. Lovely, there we are. That's the answer to this question here then. So let's move on to the next one. Pause the video and give this one a go. Right then, let's have a look at this question then. So it says the volume of the cone is 56.8 centimetres cubed and the height of the cone is 3.6. So we don't know what the radius is, so that's probably what we would need to work out first. Calculate the size of the angle AOB. Okay, so I'll get to that later. I think I need to work out the radius first. So we'll work out the radius if we know the volume is this, so we'll use volume equals 1/3 times pi times r squared h, and h is 3.6. That will equal 56.8. So let's now start rearranging this. We'll start timesing by 3, dividing by 3.6, and dividing by pi. So 56.8 divided by pi, work out that answer, times it by 3 to get rid of the third, and then divide by 3.6 to get rid of the 3.6, and I get 15.06. So therefore my r value, I'll square root my answer, give me 3.88. Okay, so I now know that that is 3.88, and now what I'll probably do is work out the curved surface area around the cone. So the curved surface area is going to be pi times the radius of 3.88 times the value L, and that will be done by a Pythagoras calculation of 3.6 squared add 3.88 squared. So let's work that out. So and that's going to equal 64.56. Now I reckon that's an important value there, so I'm going to store it in my calculator now as B. Okay, lovely, that's stored as B now. Right, so now what we need to do is we need to transfer now this curved surface area is the same area as this section of a circle here, the sector of this circle. So this sector here is 64.56. But what's its radius going to be? Because I need to work out what this angle here is. So its radius is not going to be the 3.6. It's not going to be the r value. It's going to be this diagonal length from O to A, because in the question it says from O to A, and this is O to A as well. So it's actually L. So I need to work out the length of this curve. That was the Pythagoras calculation that I did previously. 3.6 squared add 3.88 squared. 3.88 was, remember, A, so that's what I'll use in my calculation for this. 3.6 squared add A squared, and that gives me 5.29. So the radius of this circle is 5.29. Okay, so now what I need to do is the area of a sector formula, which is pi r squared, pi times 5.29 squared. In fact, that's an important value. I'm going to call it C. So store that as C. Look. No, mistyped that. Store as C. There we are. Stored as C now. My apologies. So it's pi r squared, the area of a sector, times the fraction of the circle that we're actually looking for here. And that's going to be x over 360. And this equals 64.56, and luckily earlier I stored that as B. So what I'm now going to do is rearrange this to work out what x is equal to. So I'm going to have to do lots of different things. First of all, I'll cancel out the pi by dividing by pi. So take my value for B and divide it by pi. Then I'll cancel out the 5.29 squared by doing my answer value divided by 5.29 squared. Luckily that was C on my calculator, so divide by C squared, and then times by 360 to move the 60 onto the other side. It's to divide, so we times it onto the other side, and we get x is 264. Wow, that was a difficult question, that one. I actually had to pause the video and think about that quite carefully there. So there we are, 264 is the degree of AOB of sector AO, so OACB, correct, 3 significant figures. Lovely, yes, that's the right answer. So let's move on to the next one. Pause the video and give this question a go. Right then, so we have a radius here of a hemisphere 3r and a radius of the base cone 3r as well. The height of the cone is 4r. The volume of the solid shape is 330 pi. Okay, so let's work out the volume of this shape. First of all, we need the cone formula. So that's going to be a third pi times 3r, that's going to be squared, and then times 4r, that's for the height. And then we'll add on the volume of the hemisphere, which is We don't have the formula for hemisphere here, but I've remembered it. 2/3 pi, and then it's r cubed, so it's going to be 3r cubed. Remember, a sphere is 4/3, so a hemisphere is 2/3. So if we expand all the numbers out on this, but expand the algebra first, that's going to be r cubed, and so is this one at the back. That one's going to be r cubed as well. Let's now multiply the numbers together, so it's going to be 9 times 4 divided by 3 for the third at the front, so that's going to make it 12 pi, and this number at the front here is going to be 2/3 times 27, which will make it 18. So in total, this is going to be 30 pi r cubed. Now we're told here that the volume of the solid shape is 330, so it's going to be 30 pi r cubed equals 330 pi. So we'll cancel out the pi on both sides, and we'll cancel out the 30 on both sides to leave us with r cubed equals 11. So therefore r is the cube root of 11. And there we are, that's the answer for this question here. So n in this question is representing 11. Lovely, that one was not too bad. I think we're getting a bit better at these ones now. So I forgot to put the pi in there. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so in this question here, we have the cone with height h. The radius of the base of the cone is 3 times the radius of the sphere. So if this is 3r, this one here is r. Given that the volume of the sphere is equal to the volume of the cone, find an expression for the radius of the sphere in terms of h. Okay, so if the volumes are now equal, we can say that 4/3 pi r cubed equals 1/3 pi 3r squared times h. So if we now cancel out these pi's and cancel out the thirds on these, what do we get? We get 4r cubed equals 9r squared h. So now if we divide the 9 onto the other side, we get 4r cubed over 9 equals r squared h, and then I'm going to divide both sides by r squared, so r cubed divided by r squared, that's going to be r times r times r divided by r times r. If we cancel out 2 r's from the top and the bottom of these fractions, then r cubed divided by r squared is just an r, so it's going to be 4r over 9 equals h, and there we are, h equals 4r over 9. Okay, let's move on to the next question. Pause the video and give this one a go. Right then, so in this question here we have a cylinder of radius r and I assume height h. If the total surface area of the cylinder divided by the total surface area of the sphere is 2, find the volume of the cylinder divided by the volume of the sphere. Right, okay, let's go through this one then. So the total surface area of the cylinder, that's going to be pi r squared, 2 pi r squareds from the top and the bottom, 2 pi r squared add. Now when you unravel this part of the Pringles tube effectively, you get a rectangle. And the height of the rectangle will be h, but the width of the rectangle will be the circumference of this circle here, which is 2 pi r. So it's going to be 2 pi r h. That's the total surface area of the cylinder. Now we want the total surface area of the sphere, and that's going to be 4 pi r squared. So now that we know that when we do 1 divided by the other we get 2, so they're not equal, but when we do 2 pi r squared add 2 pi r h divided by the surface area of the sphere, 4 pi r squared, we get 2. So how is this going to help us? Well, let's maybe times this thing onto the other side. So 2 pi r squared plus 2 pi r h equals 8 pi r squared. Take away the 8 pi r squared onto the other side, so we get 2 pi r h equals 6 pi r squared. Now we'll divide by pi on both sides, divide by one of the r's on both sides, and divide by 2 on both sides, so we get h equals 3r. So now we know the height. We know the height is 3r. And that's very helpful for what we're now going to do next. So we want to now do the volume of the cylinder, which is going to be pi r squared times h, and that's 3r now, divided by the volume of the sphere. The volume of the sphere is 4/3 pi r cubed. So if we cancel out the r's on the top and the bottom, we've got 3 on the top and 3 on the bottom. Cancel out the pi's on the top and the bottom. That's going to leave us with 3 over 4/3. And now we're just dividing fractions. 3 divided by 4/3. So how do you divide a fraction? You kiss and flip. So 3 times 3/4. That's going to be 9 over 4. So 9 over 4 is the answer for this question here. That was a very difficult question, Alex. I didn't know that I needed to find h in terms of r until I was about this point here. And then it kind of hit me, right, I need to rearrange this equation and work out what h is, because then I need to get the ratio from my cylinder to sphere. Right, difficult question, that one, but hopefully you've understood the workings there. And we've got a couple more to go now. Pause the video and give this one a go. Right then, so the height of the cone is 12 centimeters and the radius of the base of the cone is 4 centimeters. The question we need to start off with first is the curved surface area of the cone. So nothing to do with the cylinder yet, we'll come on to that in part B, but the curved surface area of the cone is going to be C equals pi times r, which is 4, times L, that's going to be the length of the diagonal here, which is going to be 12 squared, that's a right angled triangle here, 12 squared plus 4 squared, square rooted, so 12 squared plus 4 squared, and that's going to equal, let's do the 12 squared plus 4 squared square rooted first, that's going to be this 4 root 10, 4 root 10, so it's going to be times all that together, so times 4 times pi, to 3 significant figures is 159 centimeters squared. Not too bad, that one, but when we move on to part B, it will be quite tricky. So let's have a look at what part B is. The cylinder has a radius r and a volume v. Show that v equals 12 pi r squared minus 3 pi r cubed. Okay, so it took some while for me to get through thinking about this, but what I eventually sussed out was if you take the right angle triangle here, then that will, and we'll redraw it over here, then this will have a height of 12 and a base of 4. And then if we take the smaller triangle inside here, you see on the top there, that will have a radius r. So therefore the height is therefore going to be in the same ratio because they are similar triangles, so that's going to be 3r. Okay, now how does that help us? Because now what we can say is that the height of the cylinder is going to be 12 minus 3r. So the height of the cylinder is going to be 12 minus 3r with a radius r. So therefore the volume is going to be pi r squared, that's the area of the cross section, times the height. So it's going to be 12 minus 3r, not r squared, just r. And then when we expand the brackets, it's going to be 12 pi r squared minus 3 pi r cubed. And that's expanding the brackets there and there. So there we are, that took me some while to think of. I paused the video and then presented my answer, but it did take some working through there. It did take me drawing through some right angled triangles on the shape, spotting similar triangles, very difficult there, working out an algebraic expression for the height, and then expanding the brackets to give the volume. Very difficult question, that one. That's why it's the last question on the video. So hopefully you found this video helpful. Hopefully you've now sussed how to do pyramids, cones and spheres. And thanks very much for watching. Feel free to come back to this video at a future time and there's lots more on the YouTube channel as well. So thanks very much for watching.